always, when you're solving any absolute value equation or inequality, what do you always do first? Good, good. Isolate the absolute values. Very good. Right, so we got to get the absolute value by itself on one side of the inequality or equation. So what does that amount to here? What's the only thing I have to do? Divide by -2. Okay, and that gives us the absolute value by itself equals positive 18. And then inside the absolute value, we've got a 3x minus 9. Okay, so I isolated the absolute value. Once you isolate the absolute value, here's that critical step. We're going to trade the absolute value thing, inequality or equation, or two regular equations or inequalities without absolute values. We can't go any further till we're able to write this without absolute values. So what are the two equations that, I'm going to put an or sign in the middle. What are the two equations we're going to get from this? Negative 3x minus 9, so whatever's inside either equals 18 or whatever's inside equals negative 18. And just solve them both. You get two solutions, right? Okay, and you can do that. From there, it's piece of cake. What about this one? What are the two steps? Add 2. Okay, so I'm going to add 2 to both sides. That gives me 2 times the absolute value is greater than or equal to 56. What's next?
Divide by 2.
Divide by 2. Good, and so then I isolate the absolute value, and I get it's greater than or equal to 28. So here's the question then. If I isolate an absolute value inequality, and I have an isolated absolute value is greater than a number, does it make an and compound inequality or an or compound inequality? Or, good, makes or. And the way you remember that, yes sir?
Oh, kind of.
Yeah. The way you remember that is because the absolute value stands for a distance from the middle, right? It's a distance from some place on the number line. And this is saying we want every place on the number line that has a distance that's greater than 28 away from someplace, right? What's that look like? If I were to graph that, that means I've got some center here, and I've got, if I go this direction, 28, or that direction, 28, I got to be bigger than that, right? My distances are bigger, so it's oars on a boat, right? It's two separate distributions, so it's an or inequality. That's what we associate with an or. So how do I set that up then? What's inside has to be what? Yeah, it's either got to be really big and positive or really big and negative. What do you think? How do I say that? 2x minus 14 is either going to be good. It's either going to be greater than the positive, or what's inside is what? Less than the negative. Now, what some people said was it's greater than the positive or it's greater than the negative. Right? It's got to be greater than the positive or less than the negative. And then I just solve them both. Right? And I get two different parts of my solution. I get x is greater than something or x is less than something else, right? Okay? Last one. How about this one? Subtract 12, or you're going to tell me that. Subtract 12. So then I get 3 times the absolute value is less than or equal to 48. Divide by 3, right? And so that's going to give me the isolated absolute value is less than or equal to 16. Now what's this one going to do? If I have an isolated absolute value, it's less than a number, what's that? And. It's an and, isn't it? Because now we want distances that are small. It's going to look, when I graph that distribution, it's going to look like this. I've got my endpoints, and I want everything in between. The distances that are less than 16 away from some middle point, right? So it looks like one distribution with two endpoints, and that tells us and, right? So how do I write this then? How do I say an and compound inequality? That goes in the middle, good. 2x plus 6 is in the middle, and it's going to be greater than or equal to negative 16 and less than or equal to 16, and then I just isolate x. Okay, good. All right, so here's where we left off on Wednesday, right? We were talking about horizontal and vertical lines, and we spent some time talking about that, right? About how vertical lines are named by x equals a number, right? Whatever the x-intercept is. Horizontal lines are named by y equals a number, whatever the y-intercept is. We said that parallel lines have equal slopes, perpendicular lines have opposite reciprocal slopes. And we looked at a couple examples, right? We looked at one example at least, right? We wanted to compare these two lines and see if they're parallel or perpendicular. And here's where we kind of got cut off. So let's pick up where we left off. So what was our strategy now? If we wanted to find the slope of the red line, our strategy was if we write that in slope-intercept form, it's easy to see, right? Because the slope is always whatever the number is in front of x, when I put it in slope-intercept form, right? And if I do that, I just got to isolate the y. So all we had to do was get rid of the x term by adding x to both sides and then divide by 8, and we got y equals x. So that tells us that's in mx plus b form. The slope is 1 and b is 0 because there's nothing being added to the end. But we don't even care about the b. All we care about is the slope. The slope is 1, right? What about this other line right here, the blue line? That's an easy one. What do I have to do to isolate the y there? Subtract the x, okay? Good. Okay, what's x, Rodney? If I subtract x from both sides, I end up, the x's cancel, I get negative y equals, I'm going to put the x term first, so I get a negative x plus 4. What's the last step to get that y by itself?
Divide by -1.
Divide by -1 or multiply by -1. I'm going to show it this way. I think it's easier to show multiplication. They accomplish the same thing, but watch how you can show that work. If I just go like that, then I'm going to distribute that negative to everything. Everybody see that? So we end up with this becomes positive, that becomes positive, that becomes negative. So what's the slope? It's 1, isn't it? Good. So the slope is 1 because that's what the coefficient of x is. So are those lines parallel or perpendicular? Parallel. You got equal slopes. Good. Bottom one is super quick because I've already got it written. In a very convenient form. They're already written in slope-intercept forms. Mackenzie, what's the slope of the top line up here? We'll make that one red. 5, right? Yeah, 5. The number in front of x. You knew what you were saying. Okay. How about the bottom one? What do you think, Marcus?
-1.
So what's that tell us? Perpendicular, because they're opposite reciprocals, right? They're opposite signs and they're the reciprocal of each other. Okay, so that one has to be perpendicular, right? Okay, so the next thing we wanted to look at, and I think we'll skip this. Next thing we wanted to look at was x and y intercepts. Okay, x and y intercepts. X-intercept is just the point where, you know what that is, where a line intersects the x-axis, and the y-intercept is where a line intersects the y-axis. So, which one is that? X or y-intercept? Which one is that? It'd be y, wouldn't it? Just on the y-axis. So that's where the line is crossing the y-axis, so that's the y-intercept. So what is the y-intercept in this case? You could, I think, I mean, just hard to count, 4, right? 4. That's one way to say it. We could say it's 4, because if we say what is the y-intercept, I guess we can kind of infer that we're talking about a number, right? And that's okay, you can write it as a number. But there's another way to write it too. I could also write it as an ordered pair. What would the ordered pair be? 0, 5, okay? Now, the 0 is important. Every number on the y-axis, therefore every y-intercept, always has to have an x-coordinate of 0, doesn't it? Okay, hold that thought. That's important. What is the x-intercept? Almost. You said 3. I'm gonna -3. There we go. Maybe I just did misheard that. Didn't hear the negative. So what are the coordinates of the x-intercept? Okay, and once again, the 0 is important, right? Because every point on the x-axis, and therefore every x-intercept, always, when we close those Chromebooks up, please. And therefore every x-intercept has to have a y-coordinate of 0, right? Okay, so this is, I'll fill this stuff in, but I don't really care about this for now. Just add this to your notes. But it's not really that big a deal for now. We'll come back to this. An x-intercept can also be called a root, a 0, or a solution to the equation. Okay. We'll come back to that stuff later. What if we want to find x-intercepts of an equation? What do? Well, to find the x-intercept, which one was that, blue or that was the red? To find the x-intercept of an equation, all we have to do is set the y equal to 0 and solve for x. Right? How come? Because every x-intercept has a y-coordinate of 0. Right? To find the y-intercept, all we have to do is set x equal to 0 in the equation and solve for y. Okay, so let's take this equation right here. Y equals -2x plus 5. Let me write that a little bigger. Okay, so now everybody, eyes up here. I want everybody to see this. So if that's my equation, and I want to find the x-intercept, how am I going to do it? We can make this super easy. There's a little trick here. I'll show you. This is really nice. To find the x-intercept, what do? It's going to be where what equals 0? The x-intercept. You told me up here, the x-intercept, right there, was where y equals 0, right? Okay, so you know y is going to equal 0 at the x-intercept. It has to. So in this equation, if I want to find the x-intercept, all I've got to do is set y equal to 0, right? So I end up with 0 equals -2x plus 5 is my equation. Just solve for x, right? I know y has to be 0 to find the x value, solve for it. What are the 2 steps to get x by itself? Subtract 5, so I get -5 equals -2x, and then divide by -2, and what's that going to give me? X equals 5 halves. I get negative divided by negative is positive, and I get 5 halves, right? So the x-intercept is going to have coordinates. If I want to write it with coordinates, it's going to have coordinates 5 halves, 0. Right? You see that? How about finding the y-intercept? To find the y-intercept, what do? This is super easy in this case. What's equal to 0 for the y-intercept? X is 0. Okay, now this is a great trick. You can use this in like we use this kind of stuff in calculus a lot. There's actually a method called the Heaviside cover-up method in calculus where we're going to use this exact same trick. It's just a little higher level thing that we're doing, but it's the same exact idea. So if I set x equal to 0, I get y equals -2 times 0 plus 5. Well, what's -2 times 0? 0, right? So we automatically know that that term right there is just going to be 0. I can just cross it out. And what do I end up with? Well, y equals 5. And so then as an ordered pair, I just get I get 0, 5. So what's the trick? Here's a trick you can do. You can just do this one in your head. If I'm looking for the y-intercept, I just cover up the x term because the x is going to go to 0. So when I multiply anything by x, it becomes 0. And then solve the remaining equation for y. You can do it in your head. Y equals 5. If I want to solve for the x-intercept, I cover up y and solve for x. You can do it in your head. Right? You can do. Everybody can subtract 5 and divide by -2 in their head. Okay? It's easy. All right, so let's look at a couple quick examples of this thing. We want to find, because this is a technique we can use. How many points does it take to graph a line? 2. We only need 2, right? That's our strategy. We always start with a point. Yeah. We always start with a point, and then we create a second point and connect and extend, right? So if we can just get 2 points, we can connect and extend to graph a line. The 2 points we get could be the intercepts. That's a convenient way to do it. In this case right here, we probably wouldn't do it that way. We would use the y-intercept in a slope triangle. That's almost easier. Yeah, go ahead. Right, does that make sense? Okay, but we could. I just want to show you that we could. So if I want to find the x-intercept, we set y equal to 0, right? So to find the x-intercept, if we let y equals 0, what do we get? 0 equals -6/5 x plus 2. So what are the 2 steps to get the x by itself? Subtract 2, right? So we're going to end up with a -2 equals -6/5 x. Now I want you to pause for a second here because this is a really important step. Everybody, I want everyone's attention up here. Everybody's attention up here. Gotta get everybody on this one. Okay, that needs to be away. Next time I'm taking that to the office. When I'm talking, that's away, please. In your pocket, unplugged away, please. Yeah, I'm not gonna have that anymore. So what do I do to get the x by itself? If I want to undo multiplying by a fraction, what do I do? Okay, I could clear the fraction. I could do that. I could multiply everything by 5 to get rid of to clear the fractions, and then divide by -6, right? I could do that. But if all I've got is something simple like this, where there's just one thing on the left and one thing on the right like this, let's just do it all at once. If that were a regular number, what if that were a 10? What would you do to get the x by itself? Divide by 10, right? It's not a 10, it's a fraction. So logically you think, well, we divide by the fraction, which we do, but instead of dividing by fractions, there's an easier way. What do we always do? Multiply by the reciprocal. It's the same as dividing by a fraction, but much easier, right? So we'll multiply each side through by the reciprocal of -6/5. What is that? -5/6. That's it, right? That's all we have to do. And so on this side, that cancels out the other fraction, which is what I wanted to do, and I get my x. And then what about over here? I just multiply fractions straight across, right? So I'm going to get a 10 on the top, -5 times -2, and a 6 on the bottom. And can I reduce that? Yeah. What would it be? 5/3, yeah. So we end up with x equals 5/3, and so we get the point 5/3. Five-thirds 0, right? And so there's 1 point on my graph. That's not a very convenient one, is it? 5/3. If I write that as a mixed number, what is 5/3? 3 goes into 5 how many times? How many left over? 2.
Tell them to go home.
Oh, okay, that's fine. You go check out. Yeah. So 1 2/3 is the x-intercept, right? So we just go over 1 2/3, so it's right about there. It's not a convenient place, but it's still a point on the graph that we can estimate, right? That's 1 point. Now we need the other one. This one's easy. To find the other one, we're going to let x equals 0, and that's a piece of cake. Look at that equation right there. And if x is 0, what is y equal to? 2. Right, that term goes away. Agreed? So if x is 0, y equals 2, and so we get the point 0, 2. So there's my other point right there. And here's my line. You see? Okay. That's not, like I say, I wouldn't have done it that way. If it's in slope-intercept form, you just use the y-intercept and use the slope triangle to get a second point. Here's where it's really useful, is when you're doing a problem that's not like this, that's not in y equals mx plus b form, right? Okay, so what am I going to do here with this one? If I want to graph this line. This is a good one to really think about. A lot of stuff going on here that you're probably thinking, oh, man, those fractions, right? So you got to deal with the fractions first of all. So if I want to find the y-intercept, I'm going to let x equal to 0. Set x equal to 0. So x equals 0. If I set x equal to 0, that term just goes away. And I end up with the equation 5/6 y equals 6. Okay, that's not so bad. What do I have to do to undo multiplying the y by 5/6?
Multiply by 6.
Multiply by 6/5. And really 6 is just 6 over 1, right? So what do we end up with then? These guys cancel. And I get y equals, if I multiply straight across, I get 36 over 5. Not very convenient, right? But if I think of that as a mixed number, how many times does 5 divide into 36? 7 times, with how many left over? 1. Good, so 7 and 1/5. So we're going to have a point on the y-axis up 1, 2, 3, 4, 5, 6, 7 and 1/5. So just, about there, right? There's 1 point. How about to find the x-intercept? That's where y equals 0. So if I cover up the y term, right, let y equals 0, what do I get? 5 halves x equals 6. What do I do here? Nancy, what am I going to do to get the x by itself here? Multiply both sides by 2/5. Very good. And so those guys will cancel. I get x equals, if I multiply straight across, 12 over 5 as a mixed number. And I hate writing mixed numbers up here, because I'm always telling you never write them. You would never want to give an answer as a mixed number. But for the purposes of graphing, do you see why it's useful here? Right? So 5 goes into 12 how many times? 2. How many left over? 2. So 2 and 2/5. Good. There's our, so 2 and 2/5, right about there. Okay, and then here's our line there. Something like that. And we're good. Make sense? Okay? All right, so how about, did we finish up that's the part we didn't finish up on the e-ticket, right? From last time? Oh, you did? Okay, so if you don't have one of these, come grab, not that one. Where are those? Did I not? I gave you this e-ticket.
Yeah, you did.
Okay, you got it? Okay, good, so you've got it. Why don't you try to finish that up today? And if you get finished, there's an assignment up there. The 2.2 practice 2 assignment is the one you cover. Very short. See if you can get through that stuff. You don't know how to eat it, so let me print it off. Yes. Yep, that one. Yeah, you're all set. Yeah. If you're done, stick them in the basket, please. Period 5 basket.
Is there like an answer?
Yeah, there is. I'll put them up. Answers, I'll put up here. Yeah, let me print those out. Oh, here it is. Here's the e-ticket if you don't have it. Okay, and then I'm gonna put all this stuff, I'm gonna get rid of all the stuff from Unit 1 over here and recycle it, and only put the Unit 2 stuff over here. So if you need it, it'll be over there. You may. Okay, and thank you. Yep. All right. Okay, and then when you're done, turn those in. The 2.2 practice 2 assignment is already up on Moodle, and you could, if you're done with everything, jump on that. So I did put solutions up here.